Hello everyone, welcome back. Here is Ali Talabi. We are in module 6 and this is the second lesson. So in the previous lesson we talked about bonds, and I promise I'm going to talk about bonds valuation today and how you can find the bond price, and also we'll talk about the interest rate, YTM, and how actual interest rate impacts on the bond price. So we came to the point. Bond price is actually based on the present value of annuities and lump sum. So you have several equal cash flows, which we remember from our time value of money conversation. We call that annuities. So the first portion, as you see in the formula, is showing the present value of all these cash flows or annuities. And the second portion is showing the present value of the lump sum, which is happening at expiry date. So if you find the present value of these two cash flows, you can find the value of the bond. So for example, if you go back to the example we talked about that in the previous class, so we talk about three equal $100 payments. Also, we talk about $1,000. So you can find the present value of these annuities first. So $100, 1, 2, and $100, 3. And also you can find the present value of these $1,000, which is your face value. So, and if you add the present value of all these two cash flow streams, you can find the bond price. However, sometimes it might be a bit complicated, or time-taking, time-consuming to find the present value using the formula. So I highly encourage you to use the financial calculator, and we talk about using financial calculator, and I'm going to show you again today how to use your calculator to find the value of the bond. So let's use this example, and let's find the bond price using our financial calculator. So what's happening here? As you know, we have five major variables, and we learned this from the time value of money conversation. When it comes to finding the present value of any cash flow. So the first one was NI per year. Here it was PV, PMT, and FV. So again, I'm referring to this calculator, BA2 Plus Texas Instrument. That's the calculator I'm using. There are tons of financial calculator you can use, and the functionality more or less is same. Now, what's happening here? Back to our example, N is showing the number of periods. In our case, we talk about 3-year bonds, so your N should be 3. I'm going just to deal with I later, so I'm going to talk about I later, but for now, let's look at some other variables. The PV, that's the present value of your bond. That's the number you're looking for. The payment is $100, so that's the cash flow you receive. I'm going to leave it as a positive cash flow. That's a cash inflow. The future value is actually same as your face value. It's a kind of coincidence. Both are FV. But remember, in your calculator, FV is a future value. In our conversation, we talk about face value or par value of the bond, which in our case is $1,000. That's the money you expect to receive at expiry date, which in our case is 3 years from now. So what about the I or discount rate? I mentioned, be careful. The discount rate is not same as the coupon rate. In our example, the coupon rate is 10%. The discount rate or interest rate, that's your expected return as an investor, as a bond holder. That's the return you expect to receive on this specific bond, which might be less than 10%, which might be greater than 10%, or it might be same as 10%. So let's go with 12% for this. So let's assume that your expected return on similar bonds is 12%. So I'm going to use these numbers to find the present value of this bond. So 3N, 12I, PMT 100, and 1,000 is your future value. You are computing the present value. So when you compute the present value, and you're using your calculator, you get a negative number of $951, also 900, almost $952. So that's uh, actually your present value, $952. So let me write it down just below the present value to avoid any confusion. So I'm kind of highlighting this negative sign here. And why is that? Because we learn in time value of money that your present value and future value most of times are moving in opposite direction. So if your future value is positive, the present value most of times is negative. So, and the argument interpretation is clear because you receive the payment of $100 and you receive as much as the face value at expiry date, but you have to pay for the bonds now, so you have to buy it. And payment here, it means that's cash outflows. You are paying $952 for this bond. Now, what happened? You notice I used 12% as my discount rate or interest rate, or we call that YTM as well, yield to maturity. And this 12% is actually greater than the coupon rate, which was 10%. So your coupon rate was 10%, gave us $100 coupon payment. Your expected return is 12%. Since what you are asking for, what you want, which is 12%, is greater than what actually you are receiving, the coupon payment or the coupon rate of 10%, you are paying less than face value. In this case, we say the bonds are sold at discount. So when the bonds are sold at discount, it means the value of the bond is less than par value, which is less than $1,000. As you increase the interest rate, as you increase the discount rate, as you increase the YTM, the present value of the bond is going down. Now, if I change my discount rate, so let's assume that instead of 12%, my expected return, my required return here is just 8%, which is less than 10%, which was my coupon rate. So we want to see what happens to the present value. So again, 3N, 8I, 100 PMT, 1000 future value. You're computing the present value. So what's happening here? As we expected, now the price going above, so this is 952 and the new price is minus 1051.5. So it means you need to pay more now. As the discount rate is going down from 12% to 8%, you have to pay more. How much more? It's even more than the face value, which was $1,000. In this case, we are saying the bonds are sold at premium. And you're right, if you just change your discount rate to 10%, which is same as the coupon rate, you will end up with exact $1,000 present value of the bond. And again, it's not coincidence. If the discount rate or I or YTM is same as the coupon rate, the bonds are sold at par, which is same as face value, $1,000. Now, if you look at this example, this is another example. Here it's showing that as the interest rates are going up, so you will see that interest rate is going up from 5.1% to 15%. The value of the bond is going down. So the interest rate, that's the discount rate we talk about. That's the YTM we talk about. We are not changing the coupon rate. In this case, it's 6.5%. And this is actually for the 3-year bond. So if you use the 3-year and 3 years, you will see that given the coupon rate and given the interest rate, if you use your calculator, that's the bond price you will find. So again, we can conclude that if the interest rate or discount rate or YTM is less than coupon rate, the price of the bond will be greater than the face value, which will say the bonds are sold at premium. If the coupon rate is same as the interest rate or YTM, we'll say the bonds are sold at par, which means the price of the bond is same as the face value. And finally, if the discount rate or interest rate in this case is greater than the coupon rate, the bond's price is less than the face value, which means the bonds are sold at a discount. However, remember, it doesn't matter the bonds are sold at premium or at discount. As you are approaching to expiry date, the value of the bond is getting closer to the face value. Now, look at this. Look at this graph. Here is the whole argument. Here is the expiry date. So as we are moving forward, we are approaching to expiry date, and we are talking about three different bonds. The one on the top is sold at premium, the one in the middle is sold at par, and the one at the bottom is sold at discount. But as we are moving to expiry date, whatever bond you have, you see the bond price is getting closer or approaching to the face value, which in this case is, let's say, $100. So that's the whole argument. As you are further away from the expiry date, the premium on those bonds which are sold at premium is getting wider and wider, and same for the discount bond. The price is getting actually the bond price is getting further away from the face value. We can expand the argument regarding the relationship between the coupon rate and the YTM, and you can add the current yield as well. We will learn that the current yield is actually the coupon payment, so we call that C, divided by the value of the bond or the bond price. So if the bonds are sold at a premium, the current yield will be greater than the YTM and is less than the coupon rate. So just to explain this concept or this notion, remember the coupon rate was the coupon payment divided by face value, which by default we say is $1,000. So just let me write it down as the face value. And we know when the bonds are sold at premium, the face value is 1,000. The bond price should be greater than $1,000. So you're talking about two ratios. The numerators are same. Both they have the coupon payment. The current yield has the bond price in denominator, which is greater than $1,000. So what will happen in this case? The whole ratio becomes smaller. That's why the current yield for the premium bonds is less than coupon rate. With the same argument, you can say for the discount bond, the current yield is greater than the coupon rate. So we already talked about that before. So in this case, since the coupon rate is always greater than YTM for the premium bonds, so you can go with this argument that coupon rate is greater than current yield and current yield is greater than YTM for the premium bonds. When it comes to discount bonds, you can say that YTM is always greater than current yield and the current yield is greater than the coupon rate. And you're right, for the par value bonds, all of them are same. The coupon rate, the current yield, and the YTM are same, and all of them are actually will give you the same number. So whatever you talk about, all of them will give you the same number. So this is a kind of very important inequality. So you will see some question, and it's very common in some of the quizzes, multiple choice quizzes. You need to use this inequality to find your answer. So that's it for today. Thank you very much. We'll wrap up our lesson, the next our module, the next lesson, and we'll talk about some other topics related to bonds. Specifically, we'll talk about default risk, and also I will introduce you some important features of the bonds. So have a wonderful day. Talk to you soon. Bye. Here is Ali Talabi.